recorded, so please don't curse. All right. In P1 and P2, we're going to talk a lot about graphing. So there's some basics that you probably should know. For example, where the different quadrants are. First of all, quadrant 1 is here, quadrant 2, quadrant 3, quadrant 4. And it's just one of those things that you're going to have to memorize. And then also you probably should know that the y-axis is the vertical axis, the x-axis is the horizontal axis. And when you're talking about coordinates, you always write them alphabetically x, y, which means that all the coordinates in quadrant 1 are positive or plus plus. The ones in the second quadrant are negative, positive, third quadrant, negative, negative, and fourth quadrant, positive, negative. And so what they're talking about here is what will the signs be on the numbers that you're writing down in each of those different quadrants. There is, of course, one other thing probably about the axes that you need to know. The center dot here, that's called the origin, with the coordinates 0, 0, of course. Questions? Down below, I may have to move some of this stuff over. We have some points that we're supposed to plot. So at A, when we're plotting negative 5, 3, you go 5 to the left, 3 up. Here's A. B is negative 3, negative 3, which means it's in the third quadrant. And then C is 2, negative 1. So 2 to the right, 1 down in the fourth quadrant. Again, at any time if I'm going too fast, please just slow me down. As I look at these points, the next group of points says translate each point 3 units to the right and 2 down. And they have this little mark, which oftentimes denote the word image. In calculus, you'll probably use the word prime. Basically, it means where you moved it, where was the translation of that point. So as I move these points, here's what happens. A goes 3 right and 2 down, 3 to the right, 2 down. This is what they call A image. Its new coordinate is negative 2, positive 1. Not being infallible, of course, if I make a mistake, please just let me know. Sometimes reading and writing vertically is a little more challenging than horizontally. B image is 3 to the right and 2 down. And so 3 to the right and 2 down for B image puts me at 0, negative 4, looks like.
No, it's negative 5.
What?
0, negative 5.
Oh, negative 5. I only went down 1. Good call. Thank you. So here's B, 3 right, 2 down, B image, 0, and negative 5. Good job. And then C, if I go 3 to the right and 2 down, looks like I'm at 5, negative 3. And you could have looked at the coordinates up above and just added 3 to every x value and subtracted 2 off every y value, or you could actually work on the coordinate axes. So there are 2 ways to do it, algebraically and graphically. Questions? In the next one, there are 2 formulas that we need to recall. One's midpoint. That's basically where you add up the x values, chop it in half, add up the y values, chop it in half, and write them as a new coordinate. And then there's a distance formula where you take the 2 x values, subtract, and square. Take the 2 y values, subtract, square, add them together, and square root. And so we're not going to do a ton of these, but I figure we should probably do a small example from each of them. So in letter C, let's do the first one. Let's just talk about the midpoint from A to C. If I'm looking at the midpoint from A to C, right here, that means from up above, I'm going from A to C. Sometimes it's confusing because we have the images right afterwards. So from A to C, I add up the 2 x values. So that's negative 5 plus 2. Chop that in half. Add up the 2 y values, 3 and negative 1. Chop that in half. and then write it as an ordered pair. So negative 5 plus 2 is negative 3. And 3 and negative 1 is positive 2 divided by 2 is positive 1. And so my coordinates would be negative 3 halves 1. If you wrote it as negative 1.5, that's fine. Negative 1 and 1/2, that's fine. Get used to what they call an improper fraction, where it's just the 3 over the 2. That'll be a lot more useful later on in certain topics in our course. Looking at distances, if I want to find distances, I could also do the distance between A and C. So A and C again is here. And the interesting thing is when you use the distance formula, even though it says x2 and x1, so usually when they're talking about that, they're talking about the 1s and the 2s mean this came from my first point, this came from my second point. Some of you might have chosen A as your first point. Some of you might have chosen C as your first point. So the order of subtraction in this case will not matter because in the end you're squaring the difference anyways. So if you make that mistake, you're going to end up okay in the long run, but you should be consistent. So for example, if I'm going to do, actually I'm going to use a different color, sorry. I'm going to use pink here. So if I'm going to find the length of AC, which is the same as the distance between those 2 points, what I would do is I would take the square root of, and I would call C my second point. So I would have parentheses 2 minus, this is for the x values, negative 5 squared plus, for the y values I'd have negative 1 minus 3 squared. And when I do that, if I simplify, I would have the square root of 2 minus negative 5 is the same as 7. So I would have 7 squared. And then negative 1 minus 3 is negative 4. And I'd be squaring that. It's very important to have the parentheses, otherwise your calculator will not understand the order of operations that you want it to perform. And this gives me the square root of 49 plus 16, or in other words, the square root of 65. Now down below, maybe I should pause there, I'm sorry. So in the next question, it talks about the original triangle in purple. Is it a right triangle? And basically what that's asking us about is when you find the distances or the lengths between each of the points, what do they add up to? So rather than go through all of them, I'm going to tell you that I found some other ones. Remember, this square root of 65 that we just wrote down was AC. So I'm just going to write down all the different pieces, and then we'll talk about how we know or not know. So first of all, AC, we just said was the square root of 65. If I looked at BC, when I did the work, I got the square root of 29. And if I found AB, that turned out to be the square root of 40, which could be simplified, but for purposes right now of finding the right triangle, we're just going to leave it. And the thing to remember about right triangles is the Pythagorean theorem, and that says that if you take a leg squared plus a leg squared equals a hypotenuse squared, or you might remember it as a squared plus b squared equals c squared, right? Oftentimes when you do the Pythagorean theorem, probably the best way to do it, convenience-wise, is to go small, medium, large, and then go small squared plus medium squared equals large squared, and see if it works. If it does, it's a right triangle. If it doesn't, it's not. So I do this. I write down, does the square root of 29 squared plus the square root of 40 squared equal the square root of 65 squared? That's the question. Now the cool thing is because squaring and square rooting are inverses, they just cancel each other out, so to speak. So we have 29 plus 40 equals 65. And then the question is, yes or no? No. So make sure you answer the question. The answer is no, it's not a right triangle. In our second page of notes today, what's going on is they're going to be talking about a circle. And really, the big thing to know about this is that this is the formula for the equation of a circle. When we get to chapter 10, we'll be talking about this formula extensively. However, for right now, they just want you to see the general idea of what this means. And what I want you to know specifically about this is there are three numbers. Everything else stays. The x and the y stay, the parentheses, all that stuff. But there are three numbers. There's an h number, there's a k number, and there's an r number. These are all numbers. So how does that translate into what's happening over here? So there's a circle, and what you're going to do is you're going to do the following. You're always going to write down x minus parentheses squared plus y minus parentheses squared equals parentheses squared. And inside of these parentheses, you are going to be placing some numbers. So there's going to be a number here, a number here, and a number here. These numbers are the h, the k, and the r. So in this particular case, the numbers that you want are -3, 2, and 4. Now in our class, it's really important to simplify when you can. So really what you should have written down is x plus 3 squared plus y minus 2 squared equals 16. So this is an equation of a circle that has a center of -3, 2 and a radius of 4. So in the second part here, since they give me the center but not a radius, this is about how far I can go. I can write down, if I want to, parentheses x minus 4 squared plus parentheses y minus 3 squared. But I have to write down r squared for right now because I don't have the radius. So if I were to draw a picture about what's actually happening, because I'm a picture person and I like to see what's up, when I have this circle, over to the side, there's a center here at 4, 3. And there's some point on the circle, this might not even be accurate, but here's a point on the circle, and they tell me that point is 7, 1. So I have the center and a point. How would I find the radius? Excellent, the distance formula. So I'm going to use the distance formula, and I'm going to find the distance from 4, 3 to 7, 1. So the way that I would do that, the distance would be the square root of 4 minus 7 squared plus 3 minus 1 squared, and take the square root. Or in other words, the square root of -3 squared plus 2 squared square root, which is the square root of 9 plus 4. Oops. Ugh, that's nasty, sorry. Which ends up with the square root of 13. Now that square root of 13 that we just wrote down there, or I just wrote down, that thing right here is my radius. Since I know my radius is the square root of 13, I'm going to be plugging it in for the r. But I'm going to have the square root of 13 squared. And they cancel each other out, which we learned a little bit ago because they're inverses. So now, since I know that my radius is the square root of 13, when I square it, I just get positive 13. Because I squared the square root of 13. What's happening in this next part, I know that when they talk about these endpoints of the diameter, there's not a center there, there's not a radius there. I have to find both. Earlier I said I'm a picture person, so off to the side here, I'm drawing a picture. This picture is not fabulous, but it's going to give me an idea of what's happening. I write a diameter down because that's what they said. These are endpoints on the diameter. One of them is -6, 3, and the other one is 4, -5. Again, this is not an accurate representation, it's a visual about what's going on. The center of the circle is in the middle of the circle. So here's my center. How do I find that? Since it's in the middle, I use the midpoint. So my center is going to be equal to -6 plus 4, chop it in half, 3 plus -5, chop it in half. So I know that my center is going to be -2 over 2, which is -1, -2 over 2, which is -1. Weird. So now I can write my equation, or at least part of it. It's x minus -1, which means plus 1, squared, plus y minus -1, which is plus 1 squared. I don't know my radius yet. That's going to be this part right here, or the other way. So right now I'm just going to write down r squared. It's like the movie Saved by the Bell show. Then, if I'm going to find my radius, I can go from the center to either one of the points. So I can pick, like, for example, my radius will be equal to, or distance, I guess, if you will. I'm going to start with -1, 1, and let's say I pick the one with the 4 and the 5. So I'd have -1 minus 4 squared plus -1 minus -5 squared. Can you please shut off your phone? Thank you. When I do this, I get the square root of -5 squared plus, is that 4? 6? Oh, no. 4 squared. Or in other words, the square root of 25 and 16, which is the square root of 41. Now, just on the last problem, we talked about if there was a square root involved. When you square the square root, it disappears. So my equation now, I'm going to erase the r squared, because r squared will be, when I square the square root, just the number 41. Next stuff looks really confusing. And it says, like, determine whether each point lies on the graph of. Looks super weird. But really, it's a super easy problem. So let's take a look at, to start with, letter B. This phrase, determine whether it lies on the graph, means plug in the numbers and see if it works. And then you just write down yes or no. So here, I'm looking at this equation, y equals 4 minus 3x. In part B, I plug in -2 for the x, 11 for the y, and see if it works. So does 11 equal 4 minus 3 times -2? Is that a yes, or is that a no? No. Because 11 would be equal to 4 plus 6, and that's a no. So the answer to the question is no. In the next one, if I were to do part C, I would write down, does -11, because that's the y value, equal 4 minus 3 times 5? Or in other words, does -11 equal 4 minus 15? Yes. So that means that that point lies on the line. In our next part here, we're just going to do what they call graphing by plotting points. I don't know about for you guys, but usually it's easiest for me if I get y by itself. Not always, but usually. Later on, I'll show you other techniques, but that's oftentimes the best. So what I'm going to do is in the first equation here, I'm going to take the 2x and move it to the right side. So oftentimes when you work with your other algebra teachers, they would talk about, oh, subtract off 2 from each side, blah, blah, blah. What I'm going to tell you is whenever something changes sides by adding or subtracting, just change the signs. So my new equation looks like this. Y equals 3 minus 2x, or negative 2x plus 3 if you like your x thing first. So it was a positive 2x on the left. It's now negative 2x on the right, or minus 2x on the right. Okay, it just saves time and space on your paper if you can do that. And then generally, I like to choose x values. Usually most people require 5 points to graph something. You only technically need 2 for a line, but 5 is oftentimes better with more detail. So for the x values, when I was a kid, and probably still to this day, most people tell you to choose like -2, -1, 0, 1, and 2 to kind of center your stuff around the origin. Does that always work? No, but oftentimes it does with the graphs they give us. So then I have to figure out, okay, what happens when I plug these numbers in? So I look in the red equation up there and I go, okay, I'm going to plug in -2. So I do that and I go 3 minus -2 times 2, or yeah, minus 2 times -2, so that's actually 4, so it should be 7, right? Please let me know if I make an error. If I put in a -1, I have 3 minus 2 times -1, so that should be 5. If I put in a 0 there, the x thing disappears because something times 0 is 0, and I get 3. Do you notice anything? Do you notice a pattern? I'm just taking off 2 each time, right? So this is going to be 1, and this is going to be -1. And then I would plot these points. Now, 7 is not on my graph, so I'm going to ignore that one. But I do have -1, 5, which is up here. I do have 0, 3, 1, 1, and 2, -1. And you should see a pattern, and this is the graph of a line that looks like so. So in this second graph, I see it's a square. I know it's a parabola. It's called a quadratic, technically, I guess, as a general function group. And I pick the same kind of values for x. So I pick -2, -1, 0, 1, and 2. And I throw those numbers in my equation. So -2 squared means -2 times -2, which is 4, minus 1, that's 3. If I put a -1 in there and I square it, I get +1, minus 1 is 0. If I throw a 0 in there, 0 squared is 0, minus 1 is -1. And then I start to see something called a mirroring effect, or a reflection. 1 squared is 1, minus 1, 0. 2 squared is 4, minus 1, 3. And I plot these points, and out pops my parabola. So -2, 3 is here. -1, 0. 0, -1. 1, oops, my bad. 1, 0, and 2, 3. And here's my parabola. So one way to make a graph is to plot points. The next part of our lesson is really only about trying to handle your calculator. So earlier I told you that for graphing it's helpful to have the y alone. In your calculator it's absolutely necessary. So I'm going to reorganize my equation by, first of all, moving my x cubed to the other side in this first graph, and I would have 3y equals 6x minus x cubed. And then, of course, I would have to divide both sides by 3. And I have y equals stuff divided by 3. Now, I wrote it that way so that when we get to the calculator, you can see what I'm going to do in order to put this in my calculator and then graph it. And really, the only thing that's going on with this exercise is, can you use your calculator to graph something? That's really only what this is about. So if you're really super comfortable with graphing on your calculator, you're good to go. I'm just going to do a few things so you can see. So let me pull out my graphing calculator. Boom, there it is. Go to mode. Make sure that all the things on the left-hand side are highlighted. If they're not, highlight them. So normal, float, radian, function, connected, sequential, blah, blah, blah. Okay, if at any time you get lost, just let me know and I'll get back to it. So I'm going to go to y equals. And from my y equals, I'm going to enter in the equation that we had the way I wrote it on the board. which what I believe was parentheses 6x minus x cubed parentheses divided by 3. Enter. So the biggest thing I'll tell you is 90% of the time when you're using your calculator, you're going to go to your calculator and go zoom up at the top here, 6. That is what they call a standard window, 10 by 10. And when you look at your graph, you'll see it's a cubic. And it's negative because the thing in front of the x cubed was a minus sign. That's why it's going down to the right instead of up to the right. So always start with zoom 6. Will that always get you the graph you want to see? No. So in the future, if zoom 6 doesn't work, you have to change your window. The way that you do that is you touch the window button and you can adjust where you want it. There is no cut and dry, always do this whenever you see this kind of thing. Start with the zoom 6. After that, change your x's and your y's. Open up a wider, taller, whatever you need in order to try and see the graph. You will have to experiment with that to actually find it. There is no one size fits all for every graph. Okay, so that's what this whole part of the lesson was about. In the next part, the only thing I really want to do is I want to talk about the equation. We're not going to do it in our calculator, but I want to tell you something really important. In part D here, in order to get the y by itself, you would have to move the x squared to the other side. So you would see this. Y squared equals 25 minus x squared. Here's the problem. In your calculator, you cannot do y squared. It's y. So you have to get rid of the squaring. How would I do that? Square root. Excellent. So I square root both sides. And here's what happens for 99% of people, because they forget something important. They write down this. Y equals the square root of 25 minus x squared. Because they were great math students. They paid attention, just like you guys, and they said you square root both sides. But here's what they forget. Whenever you square root a variable, like the x squared kind of thing, there are actually two answers that are viable. You have both the positive square root of that thing and the negative square root of that thing. There are actually two equations. What this means is that if you're putting this in your y equals in the calculator, here's what you would have to do. In y1, you would have to put down the square root of 25 minus x squared. In y2, you would have to put down the opposite of the square root of 25 minus x squared. If you look at the original equation that was there, this equation x squared plus y squared equals 25, that's the equation of a circle with a center of 0, 0 and a radius of 5. If you graph the two blue equations on your calculator, you will see that circle. If you only graph the one that we originally had in red, you'd only see the top half of the circle. So, word to the wise, when you square root a variable, you must do plus or minus, which means in your calculator there are two equations. Okay, I'm going to do one more problem with you, then I'm going to have you try one on your own. So this next, did I miss one? No. All right, so this next one's an absolute value. And for those of you who remember the patterns from transforming things, the original absolute value graph looks like this. And I know that this thing right here means that I moved right 2, and this means I moved up 1. So remembering patterns from Algebra 2, I could have just graphed that if I wanted to, but I don't necessarily have to do that. I could do what we've done before. I can make an XY table, if you remember just from the previous part of the lesson. So I could go like -2, -1, 0, 1, 2. But that's not what they're asking for in this problem. What they're asking for is using your graphing utility, which means basically your calculator. So what I want you to do is I want you to pay attention as I put this into the calculator because what they want you to understand is how to do the absolute value in there. So I go to my calculator now. And I go to my y equals. I'm going to clear out that equation so I don't have that cubic anymore. And it was the absolute value. The way that you get to absolute value is math. And I believe it's numbers. So I'm going to go to NUM. And you see that ABS. And that's not a workout kind of thing. That stands for absolute value. So I hit enter. And then I type in what's there. Like some of you might have a parentheses after ABS. That's okay. I, again, have that pretty print stuff. So then you're going to go x minus 2. And then I would move to the right, but you're going to go parentheses if you don't have those things. And then I go plus 1. Enter. And what you can see, because I have a bunch of screens on my whiteboard here, is that the absolute value has moved, the V part of it has moved 2 to the right and 1 up. I'm going to go zoom 6, excellent, zoom 6, my standard window. That's what it looks like. Now, you know, here's the truth. I can't really, these pixels are so small. When you get older, it's like really hard to see this crap. So I'm going to zoom in a little bit. So I'm going to change my window. So I go to my window because I want a better picture. And instead of going from negative 10 to 10, I'm going to go from negative 5. Uh-oh. I'm struggling because my calculator thing is not... Boom. That's not going to work. Let's see if that works. Yeah. And I'm going to do the same for my y value. What? And now when I graph, I can see a little bit better about where the V part of my absolute value went. So the big idea in this part of the lesson was, can you put something in your y equal and can you change the window to get a good look at the graph? I want you on your own to try and answer letter F. Please work with somebody else. See what you get. I'm going to have my answer key up in the front when you finish. And then when you go home for tonight, your assignment is worksheet P1, P2. I believe there are 4 problems.